Hello everyone. Let us continue with the vector operations like addition and subtraction. Now, addition and subtraction of vectors. We can add or subtract two vectors. Both the operand vectors must be of same type and must have same number of elements. Let us consider the example. A is a row vector with the elements 7, 11, 15, 23 and 9. Whereas B is also a row vector with the elements 2, 5, 13, 16, 20. Now I want to perform the addition and subtraction on these two vectors. So I'm going to write C is equal to A plus B semicolon. So it doesn't displace the C value. I'm going to write D is equal to A minus B subtraction of two vectors semicolon doesn't show the D value. So we are using disk C and disk D to get the output. So when I write disk C, the answer is addition of two vectors A and B. So 7 plus 2, 9, 11 plus 5, 16, 15 plus 13, 28, 23 plus 16, 39, 9 plus 20, 29. Similarly, D is equal to A minus B. So D is equal to 7 minus 2, 5, 11 minus 5, 6, 15 minus 13, 2, 23 minus 16, 7 and 9 minus 20 is equal to 11. Now let's see the scalar multiplication of vectors. A vector multiplied by a number is called as a scalar multiplication. Consider a row vector V is equal to 12, 34, 10 and 8. And suppose we are doing scalar multiplication, M is equal to 5 multiplied with V. So the answer is 5 into 12, 60. Similarly, 170, 50 and 40. So hence the scalar multiplication of vector V with 5 is 60, 170, 50 and 40. Next, transpose of a vector. Transpose means that the rows are changed to the columns and vice versa. Now consider the example. R is equal to 1, 2, 3, 4, a row vector. If I write TR is equal to R transpose. So here this operator is used for transpose. Then the resultant is 1, 2, 3, 4, a column vector. That means rows are changed into the columns. Next, appending the vectors. Now we can do the appending of vectors in MATLAB. So let us understand this with the help of this example. R1 is equal to 1, 2, 3, 4, a row vector. R2 is equal to 5, 6, 7, 8, another row vector. If I write R is equal to R1, R2, then the resultant is a row vector 1, 2, 3, 4, 5, 6, 7, 8. That means R1 is appended with R2. And if I write RMAT, R1 semicolon R2. Now here two row vectors are separated by semicolon. So the appending takes place as RMAT is equal to 1, 2, 3, 4. Next row it is 5, 6, 7, 8. In this way, appending of vector takes place. Now, magnitude of a vector. Magnitude of a vector V with the elements V1, V2, V3 up to n is given by the equation V is equal to under root V1 square plus V2 square plus V3 square so on up to Vn square. Now, how to take a magnitude of a vector? This follows in 3 steps. First, take the product of a vector with itself using array multiplication. This produces a vector SV whose elements are the squares of elements of V. So we write SV is equal to V into V. So it's a dot into V indicates that it's an array multiplication. Second step is use sum function to get sum of squares of elements of vector V. So here we are writing dp is equal to sum SV. Next, use square root function to get the square root of sum, which is also the magnitude of the vector V. So we write mag is equal to sqrt dp. Now let us see this example. V is equal to 1 colon 2 colon 20. So that means V is a row vector where the first element is 1, last element is 20, and in between them the elements are equally spaced by 2. Hence the V is a row vector with the elements 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. Hence, SV gives the square of V, dp gives the sum of SV, which is near about 1330. Hence, the magnitude is square root of 1330, which is nothing but 36.469. Now let us see the next example. Vector dot product. Dot product of two vectors A is equal to A1, A2, A3 up to n and B is equal to B1, B2, Bn is given by A dot B is equal to summation AI into Bi. Here, consider the example V1 is equal to 2, 3, 4, a row vector. V2 is equal to 1, 2, 3. Now if I write dp is equal to dot V1, V2, it returns the scalar dot product of V1 and V2. If V1 and V2 are the vectors, then they must have the same length. And here we have ensured that. Similarly, if V1 and V2 are matrices or multi-dimensional arrays, then they must have same size. So ensuring these two conditions, we want the result disp dot product disp dp. Hence the result is dot product is 20, which is nothing but V1 1 multiplied with V2 1. So 2 into 1 2 plus V1 2 multiplied with V2 2, that is 3 into 2 6 plus V1 3 into V2 3, that is 4 into 3 12. So the answer is 2 plus 6 plus 12, that is equal to 20. Hence the dot product of V1 and V2 is 20, is a scalar quantity. Vector dot product. Now we consider some another example. A is 1 2 3 semicolon 4 5 6 semicolon 7 8 9. It is nothing but a 3 by 3 matrix. B is similarly we are taking 9 8 7 semicolon 6 5 4 semicolon 3 2 1. And suppose if I write C is equal to dot A comma B and I want to get a result with the help of disk C, then the dot product is like this: 54, 57, 54, whereas C is a 1 into 3 matrix. How we can get the answer? C of 1 is 54 as a dot product of A colon comma 1 with B colon comma 1. So that means it is 9 into 1, 9, 6 into 4, 24, 33 into 7, 21. So the answer is 9 plus 24 plus 21. So the answer is 54. Similarly, if I write D is equal to dot A comma B comma 2, then the resultant D is a 3 into 1 matrix. So the answer is 46, 73, 46. Whereas D of 1 is 46, which is dot product of A1 comma colon with B1 comma colon. Next is the vectors with uniformly spaced elements. Consider the example V is equal to 1 colon 2 colon 20. As I told previously, it contains the first element 1, last element as a 20, but the elements are uniformly spaced by the interval 2. Hence, the vector is 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. Next, we are writing square is equal to V dot raised to 2. So, we are doing multiplication of V into V in short, or it is nothing but exponential of 2. Hence, it is disk SQV is nothing but square of V. 1 square 1, 3 square 9, similarly 5 25, 7 49, 81, 121, 169, 225, 289 and 361. So here we can have the uniformly spaced element and we can perform the operations like multiplication and exponential on the uniformly spaced elements also. Thank you so much. So here we have understood what are the different type of operations can be done on the vectors. Thank you very much.